Welcome to our Advanced Manufacturing Lab video journal. Across 3 labs, our team learned not only how to operate the Dobot Magician, but how to integrate sensors, machine vision, and multi-robot communication to build a fully automated system. In this video, we'll briefly summarize Labs 1 and 2, and then take a deeper look at Lab 3, where we combine sliding rails, I/O handshaking, and vision-guided robots. Finally, we'll connect everything that we learned from Labs 1 through 3 to our final project, an autonomous waste sorting system.
In Lab 1, we learned the essentials: powering, homing, and programming the Dobot Magician using Move J, Move L, and Jump commands. We practiced using both the suction cup and gripper end effectors and created simple, automated pick-and-place routines. We also integrated the conveyor belt and IR sensor to build branching logic that allowed the robot to react automatically when it detected an object.
In our Lab 2, we were introduced to the Dobot's machine vision. We created feature matching templates from captured images. We practiced point-to-point measurement and used a 9-point checkerboard to calibrate camera coordinates to our robot's coordinates. Our 9-point calibration used the endpoint calibration command and provided us with the necessary information to move forward with our Lab 2 and following labs. The next step was to use color extraction and blob detection. We were able to identify specific blocks based on color and move them accurately outside of the workstation until all specified blocks were removed, which was our first major step towards vision-guided automation.
In Lab 3, we had the most advanced and most valid experiences for our final project. We began by learning how to extend the robot's work area using a sliding rail, then moved into one of the most important concepts, handshaking between 2 Dobots, or two-way communication. To do this, we partnered with another team and built a resistor-based handshake circuit on a breadboard. Dobot 1 acted as the sender using the EIO13 output pin, and Dobot 2 acted as the receiver using the EIO5 input pin. We wired the LEDs to visualize when the signal was successfully sent and received. With this setup, Dobot 1 picked up a foam block, moved it near the second robot, and then sent a 1-second digital pulse. Dobot 2 continuously scanned for the signal. When the LED lit, Dobot 2 activated the sliding rail, moved to the pickup location, and grabbed the foam block. This was our first time coordinating 2 robots through the real electrical I/O, and it showed how industrial robots can communicate reliably in an automated production line.
The second half of Lab 3 expanded our machine vision skills. We created fast match templates to detect rectangles on the workspace and used the calibration file to convert image coordinates into accurate robot coordinates. One of the most technical parts was writing C# logic inside the shell module. Because the end effector can only rotate between negative 135 degrees and 135 degrees, we had to transform detected rectangle angles into reachable orientations for the Dobot. We programmed angle conversions, defined input and output parameters, and linked these script values back into the flowchart. After adjusting orientation, the Dobot picked up each rectangle and used feature matching again to find the handoff area. The robot then aligned the angle precisely and placed the rectangle into the correct handoff area with the correct orientation. This lab connected vision, coordinate transformation, scripting, and precision motion all in one workflow.
Our final project brings all the Lab 3 skills together, especially the handshaking and vision-guided manipulation. We simulated an automated waste sorting station, which is a useful real-world application for robots similar to the Dobots that we worked with. Our Dobot A identified a pile of mixed objects using the feature matching command. Then, it classified each item as trash or recycling and oriented the recyclable items using a shell module rotation script. It then placed each piece into one of 2 handoff areas that were specified as recycling or waste. Using the same handshaking principles from our Lab 3, Dobot B waited for the signal before picking up the next item in the handoff area. Dobot B then proceeded to stack the items in groups of 3 using a suction cup, and when the stack reached 3 pieces high, it used a custom 3D printed end effector to slide the stack to the side, making room for a new stack. The communication loop would continue until all objects have been sorted with no human intervention. This project would not have been possible without the skills that we developed in Lab 3 using digital I/O communication, advanced image feature matching, and C# scripting.
Lab 3 was a turning point in this course. It taught us how to combine movement, vision, scripting, and multi-robot communication into a completely automated system. By integrating everything we learned from Labs 1 and 2, we were able to build a fully autonomous waste sorting operation that demonstrates the power of robotic automation. Thank you for watching.